We are about to show the animation cycle in closer look for collisions. So construction of the cycle looks that way. We have walking flat, which we just seen, or walking step up. The first name here is what kind of animation is taken from here or from anywhere, but usually I refer to the same pack. So we are using animation walk passing right, where we have it walk passing right. So this is this animation. It is taking the whole line, so it is quite long. It is generated numerical value from the program, and this animation is moved here. Then manually I put how many frames it takes. Then it is modified in Fly by the character itself to the given degree. What should be turned, moved or turned parts. Later on, colliders. Colliders, we have list of colliders here. So it is just copy-paste kind of collider. Like here, collision as forward, which is collision as forward. And it is from detector as forward to as pivot, so to the pivot part. This is the name of the collider to be returned after collision check. This is the resolution, those 5 pixels, uniform for all collisions, more or less. Where to return information in case it return anything. So main part is like nothing. It is not important because it is a pushback. And pushback, let's see if we have any. Do we have pushback sequence? Okay. So we have push light, for example, and it is just moving us with our main position matrix in given direction. If we have anchor, it is pushing anchor. If we don't have anchor, it is pushing main ID, means main path. There are also some different kind of pushing. For example, in flight, if we collide with something in flight, it is also freezing our inertial translation, so it's stopping us from flying, and then moving us same way by given vector. Why this vector? Okay, because we are calculating how we are flying by given length. And in case of standard first version, it is very hard kind of push. We are casting vector for forward and sides. I can calculate also for up and down. This is casting a vector against another vector, and this is the length of the cast of this vector that is multiplied by the vector of the position matrix and is pushing us much harder. So different length of push. But it was a bit jaggy. So this is our collision information. For example, those initiate pushbacks. Those are just for information if we are stepping up, flat or down. Those are information too, just inertial, so they are useful for falling. If the length of the vector is longer than the character itself, I just check if this vector is colliding with something, and if it is, I'm making subsequent checks of falling. Otherwise, just fall in this direction. and those are anchors. So they return anchor to the given part. So for example, left or right toe. Later on there be for hands for climbing, and it is returning some anchor information. So it has some colliders, collision lines asked about, and this is the whole part. Later on is next part in array. So next is walking up air with right leg, walking contact, and as we see here we have colliders that just stopping us. Here we have collider that is trying to anchor us. So here the legs are checking for first time if there is any ground to stick up to, and starting the checks if the next step gonna be flat, down, or up, or something like that. Then walk down air, so contact his starting checks, maybe there be a ground, and walk down air is checking ground for real, and if there is no ground and he's still animating, double down. So he is looking for the ground in front of him much deeper and much deeper. This is kind of safety check. So he can move quite deep looking for the ground. This is just an animation. We almost never get to this point. So every animation cycle is made that way, and then cycles are switched by some behavior handler. So if we are about to perform moves on 3D in the step event, skeleton, humanoid, let's choose anything like joke cycle, and we here have resolving behavior. It is quite often called function. So he can be falling, landing, idle, walk, jump, jog, for now. So if he's falling, there is not much to choose. He's just moving his legs and arms just to be doing anything, but there is no point of doing anything. If he detects collision, he goes to landing. For now, it is hard set values if he fall hard, medium, or light, magic numbers, so it should be solved later on by the object, so there will be some values. And in case of idle, as we see here, he's reloading animation pack and cycle because structs in Game Maker Studio 2 have some maximal size, and yeah, I found it in hard way. So for jump it is another pack, another struct, and so on. For jog is also second. Okay, so if he is, for example, walking, so he's checking collision info, step up, flat, or down. So first he's checking up. If it is up, okay, no more checking, we are going up. If we are going flat, or if we are stepping down. For the jogging, I added one extra check from anchor to forward ground, because it definitely says it is a step up, and I think I can just add this collider to the walk system too, because he's making mistakes, and this jogging solution is newer than walk, so I can update it adding another check to walk cycle. So if string starts with walk, behavior cycle starts with walk, means we are already in the cycle and we are just switching legs from left to right, right to left. And then we are resolving if we are going up or down or something like that. This line is just a memory from the past. Else, if it is not starting with walk, it means we go in the walk for the first time, we're checking if we go up or down or flat or something. So here we have this check and the information is passed. And we're resolving which leg is on the ground. So if toe R, right toe is on the ground, yeah, obvious, as left toe, and if we don't find any deer string, so we have exception handling, it is right foot you have to start with. So we are on the right cycle. Same way for jumping, just we are casting a vector of our jump. So we are returning information if we are going forward, backward, right, left. So we are casting a vector on our position matrix and we are checking where our jumps go relative to our position. So it is direction. It is not used, it should be to be done with different animation for jumping right, left. For now it is only one kind of animation executed for whatever. So it is manually set jump up, start. Same we have for jogging. It is more refined, but it is almost same as walking. Just jogging have a breaking point from jogging 1 to 2 because jog 2 is in flight. So when he anchored in the jog, what do we have here? We see the jog cycle. So jog 1 and 4 is going back to 1, it's a loop. As we see, he gonna be switching legs. So only choice we have is 1, 2, 3. 3 is landing. Number 3 is landing. Is going to switch to jog 4. And in case we are starting or we have just switched, he is checking again if the next step will be up, down, or something like that. So if we go to humanoid cycle, 1 and 4 is pushing next animation in sequence. Pushback sequence is if we found a wall. If string start with behavior cycle jogging 2, it is flying, so this is pushing us to the jump. And here we are casting vector from our future. Here we do this. And if our dot versus inert gravity in next step will be changing to falling, we are resolving our behavioral cycle to step jogging 3, which is falling, and handling of jog 3 is handled here because it is a common falling cycle just in jog. So it is a reused script for falling cycle, just with different animation cycle. So here we have this falling cycle, and here is the resolution in case we have anchored. So somewhere in every of those cycles, let's choose walking cycle, it will be easier to find. We are performing pushback sequence, so if we found a wall, and then we performing collision on objects. Why are we performing sequence? Okay, we are checking any pushbacks. And then we are checking collisions for anchor any. And if there is any anchor, so here if it is any anchor, perform anchoring. Else continue animating. And at the end we are resolving controls, so input from pad or keyboard or whatever, and there it is. So here we have controls.